Can quantum superposition be explained simply? Have you ever wondered how something can be in two places at once? This idea is at the heart of quantum superposition, a concept that sounds strange but is fascinating. So, can we break it down in simple terms? Absolutely. At its core, quantum superposition means that a quantum system can exist in multiple states at the same time until it is measured or observed. This is a big departure from what we see in our everyday lives. For example, think about a coin flipped in the air. When it lands, it is either heads or tails. But in the quantum world, before you look at it, the coin can be thought of as both heads and tails at once. This both-at-once state is what we call superposition. As soon as you observe or measure the coin, the superposition collapses, and the coin chooses a definite state, either heads or tails. This is a key point in understanding quantum behavior. Another way to visualize this is through a quantum bit or qubit. And like a classical bit, which can only be a 0 or a 1, a qubit can be in a combination of both states simultaneously. Mathematically, this is shown as a weighted sum of the two states, where the weights, known as probability amplitudes, tell us the chance of measuring each outcome. Now, why does this happen? Quantum particles, like electrons, behave like waves of probability instead of tiny balls in fixed positions. These waves can overlap and combine, creating new patterns. For instance, an electron around an atom does not follow a fixed path. Instead, it exists as a cloud of probabilities that can mix different energy states at once. The weirdness of superposition is highlighted in famous experiments like the double-slit experiment. In this setup, particles create interference patterns that only make sense if each particle goes through both slits at the same time. This behavior is impossible in classical physics. Superposition is not just a theoretical idea. It has real-world applications, especially in quantum computing. Quantum computers use superposition to process many possibilities at once. This could allow them to solve certain problems much faster than classical computers. However, the superposition state is delicate and collapses upon measurement, which presents challenges for building reliable quantum machines. In the realm of unexplained physical and cosmic phenomena, superposition stands out as one of the most bizarre aspects of physics. It defies our common sense, showing that reality at the smallest scales is fundamentally different from what we experience daily. The notion that something can exist in multiple states until observed challenges our understanding of reality and observation. So, while quantum superposition may seem complex, it can indeed be explained simply. It's a perfect example of the strange and quirky nature of the quantum world, leaving us with more questions than answers about the universe we live in.